Good day friends, welcome back to the channel. It's given from Techno Drive. Today we've got this inverter. It came from Uppington, so it's a long way from our side because we're in Albertine. The inverter came all the way from Uppington. It took 2 days for us to get an inverter from Uppington because they send an inverter with courier guy. You can see the distance there, it's about 800 kilos. So it took days for us to receive the inverter. You can see when they shipped it, it was on the 26th of August, and then we received it on the 28th. So I would say it's a maximum of 2 days for the inverter to reach us. So courier guy, they are very, very helpful. So we're using them a lot to ship the inverters. So just be free when you want to ship the inverter. We will get it, then we can try and see how we can help you. So this inverter, the model number, it's FS-I008. so that's the model code on at the side of the inverter. So that's when you check at the side, you will see that model code, but at the front there's another code that some other people they use, which is WO8548. So if you type WO8548, you will get this inverter. So this is the full view of the inverter that we are going to repair today. You can check, you see this is the same inverter. So let's try and fix it and see what's wrong with it. So what we were going to do is to check the battery terminals. You see these two big terminals, these are for your battery. So we have to check the resistance there and see if there is any short circuit or anything that's disturbing the inverter, because on the inverter we shouldn't get any low resistance there. Let's check. So we are getting 3.9 ohms. So 3.9 ohms is very, very low. It's not good. So obviously it's gonna short the 48 volts. So let me get another board. I can show you what must we read on the terminals. So this one is a working board. Let's check the resistance on the working board. You can see there on the multimeter. Let's check here. You can see we are getting 75.4 kilo ohms, not the resistance that we are getting here underneath. 3.9 ohms. It's not good. So at least we should get some kilo ohms on the battery terminals. Okay, let's open the inverter and see how we can repair this. Okay, but before we can open the inverter, let me show you what's gonna happen when you connect the battery while it's like that. Okay, I now have my multimeter on the DC. Let's measure the voltage here. So this is my power supply. So I've got 24. Let me just take it up. So I've got a variable power supply. I can use the same power supply to repair 24 volts, because on the inverters you've got 24 volts, you've got the 48 volts, and you've got some 96 volts inverters. So I can just adjust the voltage. Okay, let's check now. I've adjusted it. You can see now I've got 51 volts, which is around 48 volts. It's a normal voltage. So on my power supply I've got protection. If I short it, there won't be any problem. But if you're using a battery, obviously there will be some spark. I can see some signs of spark. You see there. So they try to switch on the inverter while it has got a short. Let's connect the DC positive. and minus. You saw a spark there. Let's check the voltage. See, I've got 4 volts only. So that resistance is drawing all of the power, because we should at least have the inverter on, but we can't. Obviously with the 3 volts the inverter will never come on. So that 3 ohm is drawing all of the current, so it won't allow the inverter to come on. So that's why my power supply has got the protection. It will drop the voltage and the current if it's pulling too much. So let me show you with the working inverter what you should get. So this one, it's a working inverter. Let's check the resistance again. You can see we've got 75 kilo ohm. Let's connect the battery. Let's check the voltage. You can see I've got 50 volts. So the other one, when I connect the battery, it's giving me you see the same clamps are connected there. It's giving me 3 volts. So this one is giving me 50 volts. So it's allowing the power to flow, then the inverter can work. It's just that now I've got no control board here. The inverter won't switch on, but it should work because the voltage is not blocked by anything. So let's open that inverter. Okay, we've got the inverter opened. Let's take out the connection here for the coil. Okay, let's start by taking out this. Next, we're going to take out this plastic. Just make sure you don't lose these clips. We're going to need them after. Our plastic out. Let's now remove the MPPT board. Okay, you can see if you take a look at that MOSfet there, this one here, it bent out. Let's bring it a little bit close. So you can see that MOSfet there. So one of the MOSfet even popped out. But it doesn't mean that this is the only MOSfet that blew up, because some of the MOSfets, they can get damaged, but they don't pop up like that. It's one of them. That's just a sign to show you that there's something that was going on. So this is the problem that we are having on this inverter. But I've already mentioned on the other videos that on the inverter, once those MOSfets get damaged, you also have to take a look at these IGBTs. You see these ones, these are for the inverter side. So these ones we have to check if there's no short. And you also have you've got 1, 2, 3, 4. You've got 4. These ones, they should be for the charging. Yes, these ones are for the charging. You've got 4 this side, and that side, if you go, you've got another 5. So this one, these 2 are for the upper side of the inverter, and this other one, they are for the lower side, these 2. So this one is an active rectifier. So active rectifier, the inverter will rectify the voltage according to the need. So you've got the active rectifier IGBT on the last point. So but these 4 are your inverter. 2 for the lower stage and 2 for the upper stage. Let me show you on the schematic. Okay, this is the schematic for the aspect inverters. So you can see that on the inverters we've got the upper stage and the lower stage. So the upper stage is connected to the V bus plus, which is your DC link bus. So the lower stage is connected to the negative side. So both of them, you're gonna have a live and neutral output. So lower stage, and 1, 2 for the lower stage and 1, 2 for the upper stage. That's why you have 4 IGBTs. So those are the IGBTs that I was showing you. So you also have got this active rectifier. This is the one that I've just mentioned. So this is how the inverter works. So you also have got these MOSfets. These are your input MOSfets. You remember I showed you that one that popped up. So once you've got the short circuit there, obviously this is your battery terminals. So you've got battery minus and battery plus. So if you've got one MOSfet or some of the MOSfets that are shorted, obviously the battery terminals will get shorted. So this is how the inverters work, and those are the IGBTs that we have to check while repairing. So these are the 2 IGBTs, the upper stage and the lower stage. So which means 2 are connected to V plus and the 2 are connected to V minus. So you will get an output from there. So I've just showed you on the picture there. So you've got how many? 1, 2, 3, 4. So some of the inverters you will get like 8 IGBTs just to get more power. So here we've got only 2. So don't mind if you see these lots of IGBTs. We actually, on this inverter, we only have got 4 IGBTs that are for the inverter side. So we've got 1, 2, 3, 4. So if you parallel them, obviously you're gonna have more power, but on this case we only have got 4 IGBTs. So there's 2 that are connected on the V minus, 2 connected to V plus, and then you're gonna get your output there. You will get the live and neutral. So we have to check those if they are not short circuit. Okay, let's start checking the MOSFETs. So these are our input MOSFETs that are connected to the battery. So I've got 1, 2, 3 points that we need to check. I normally check the gate and the emitter. We've got 11 kilo ohm here, 11 kilo ohm, 11 kilo ohm, 1 ohm. So this side, so these ones we have to change 1, 2, 3, 4 MOSFETs. So the reason why we have to change 4 MOSFET is because these MOSFETs, they are connected in parallel. You see these ones, 1, 2, 3, 4. It's actually one MOSFET here. This is one MOSFET. So if you change one, it's better to change all of them, because you can't change one, they are connected together. So it's better to change all 4. And then we've got 1, 2, 3, 4. This is another MOSFET. So we've got 1, 2, 3, 4. This is another MOSFET. So if we change, we have to change all 4. And we've got another 4 last one. 1, 2, 3, 4. So this is one MOSFET. So all of these MOSFETs, the gate is connected together. Let me show you here. Okay, just take a look at the multimeter there. You see, if I connect here, I'm just gonna connect the gate. You will see that it's together. See, they've got 8 ohms. So you will get 8 ohms all over if it's not right. So it means that some of the MOSFETs here, they are not okay here. We're gonna check as well, because you see, we shouldn't get the difference in resistance. See, there we've got 8 ohms, 6 ohms, and 69 ohms. That's not good. Let's check this one. We've got 100 ohms, 100 ohms, 100 ohms. See, this is another channel now. That's why we're not reading any resistance. So these 4, they are okay. We are getting 100 ohms. Let's check the other ones. See, we've got 100, 100, 100. So these ones, they are okay. But this side, so it means that we have to change 8 MOSFETs here. So because these ones, they're no longer reading okay as well. So we are going to change from here to that side. I'm sorry, the camera was off. So we're going to change all 8 MOSFETs. It's from here to that side. So all of these we're going to change, and all of these 4 we're going to change. Because we should get the resistance similar to the other ones, which is around 100 ohms. But here we're getting a very low resistance. So obviously they've got problems. So we're going to take out these 8 MOSfets. Okay, I've just removed all of the 8 MOSfets that we had to change. So this is all of them. You can see the current rating there. It's 42 amps, 100 volts. So 42 is the current, and 10 is the voltage. So we've got 100 volts there. So because this is a 48 volts inverter, so 100 volts, it's within the range. So this is where the MOSfets were. You can see I've already opened some holes on the 4 MOSfets. I still have to open the holes for these other 4. So we've got nice holes there, so we can put new MOSfets. But before we can carry on with that job, let's just check the resistance. Gonna check the resistance on the gate. We've got 100 ohm, 100 ohm, and 100 ohm. So this is the good reading. It tells us that the resistors there, they are okay. Let's check the other gates. See, this one I've got 62. Let's put my meter, and you can see nicely. See, this one we've got 62 kilo ohm. It's not right because these 4 MOSfets, they're connected together. We should get 100 ohm, 62 kilo ohm, 62 kilo ohm. So let's check the other side. 100 ohm, 100 ohm, 62 ohm, which means this resistor here, it's gone. So it's a 51 ohm resistor. I'm going to take it a bit close, then we can see. So you can see that this resistor is 51 ohms, so that we are not getting a resistance there. So this resistor is gone. So if you check, this resistor is linked to this resistor this side, so that's why we've got 100 ohm, because we've got 51 ohms there plus 51 ohms, so it's gonna give us 100. That's why we're getting that 100 ohms. So if you check the other gate, we've got 51 and 51, it's giving you 100 ohms. So that's why I'm saying we have to change this resistor. We're not getting a 100 ohm there. So if we connect the MOSfet without that resistor, the MOSfet will not be working, it will just be there, but it's not getting power to let it go on, because this is a gate signal. So this one it's going to the gate, so you will have 15 volts if the MOSfet is on here. So if the resistor is open, that 15 volts will just end here, it won't go to the gate, so the MOSfet won't come on, it will just be there, but it's not working. So we have to change that resistor. Let's change it. Okay, I've got the resistor replaced, that 51 ohm. Let's check the resistance now. The gate, see, we're getting 100 ohm there, 100 ohm, 100 ohm. So like I've mentioned, we've got 4 MOSFETs connected in parallel. So these ones, you see, if you connect to the other side, you won't get any good resistance, you won't get 100 ohm, because this is another channel of MOSFETs. So let's check there. See, we've got 100, 100, 100. So these 2 channels that we were repairing, they are okay. So now we have to move to the IGBT side. Okay, let's check our IGBTs. I've already showed, these are the inverter IGBTs. Let's check the resistance, the gate and the emitter. We're getting 27 ohms, it's shorted. So we have to, obviously these ones, they are connected onto the high stage, so we have to change both of them. We can't change only one. So if we change one, we risk, because it can get damaged. They work together at the same time. Let's check these ones. So also 5 ohms. So 1, 2, 3, 4 IGBTs we need to change. Let's change them. So there's a big cap that we have to remove, so that we can easily remove the IGBTs. So this cap has to come out. The reason why, so if you check here, it's gonna block, that cap sits here and it's blocking the screws there. So we won't be able to take out the screws if we remove that cap. See that right there? So the screwdriver won't reach. Stick it there. So these IGBTs, I'm trying to remove them, but they are stuck because they've been here for a long time, since the customer got the inverter, and now because of the heat, so now they got so much tight in such a way that it's not easy to remove them. So we have to use a big screwdriver to just try and squeeze it. Let's try. Yeah, you hear that? It was tight. Let's check the other one. Yeah, you can hear when it's coming out. Yeah. Let's see this one. All of the 4 IGBTs. Let's remove them. Got 2 of them out. Okay, we've got all 4 IGBTs out. So here is one IGBT. So they use 60 and 65. So 60 it's the current, so it's a 60 amp, and 650 volts. 65 it's 650 volts. So if you take a look at this IGBT, it's cracked. Let's open it. See, it's bent there. See that bit of a welding? It looks like a welding. It shows you that the damage was very serious. So that's why the lower stage MOSfets are also damaged. So the IGBT is damaged. So let's replace them. So we also have to open the gates, holes, and actually all the holes needs to be opened for the new IGBTs. Okay, we've got all 4 holes opened. Let's check the resistance. I'm getting 24 kilo ohm, 17 kilo ohm, 20 kilo ohm, 20 kilo ohm. So let's check the other resistors. 46 ohm. These are the most important resistors. 46 ohm, 47 ohms. So these resistors are okay. So I'm sure even the optocouplers are okay. Let's change the IGBTs. Okay, we are now ready to replace the IGBTs, but what I've noticed is that the insulation is damaged there. So the reason is the IGBTs were stuck on the insulation. So when we remove them, it went out with some insulation. You can see on this IGBT, the insulation there, it's still there. And because this is the high frequency inverter, we really need a good insulation. We don't want to risk spikes and other things, so we have to change that insulation to make sure that when the inverter goes, it's gonna work for years. Okay, I'm gonna cut this old insulation, then we're gonna get a new insulation. Let's cut it out. So we don't want to use the new old insulation that's gonna give us a risk in future. Let's take out this insulation. Okay. So also we don't wanna leave that insulation because the heat transfer won't be good. So we have to clean that old insulation. We have to clean it until it's out so that we're gonna have a good heat transfer. Okay, this is clean enough. Let's put the new heat transfer. This is just a heat transfer compound. I'm happy with it. What do you think? It's alright, ne? I think so. Let's get new IGBTs and install them. I'm going to install new IGBTs. Just to speed up, I've installed one. You can see how it's done. And then I'm gonna install the other one. And then we can go further. Okay, I've got one IGBT in. I'm gonna install the other ones. Okay, I've got the IGBTs replaced. I'm sure they're looking good there. Alright, I've also replaced that the big large capacitor that we removed. Now we are going to change the MOSfet. Those 8 MOSfets. I've already put some here. Let's put them back. So I'm going to change all of those MOSfets. Remember, it's 8 MOSfets. It's just to put the screws and the insulation on the other side, and then I will be back now. Okay, I've replaced all of the 8 MOSfets. Okay, I just have to finish the soldering there. You can see the soldering is not complete on the 4 MOSfets. So I'm just going to solder those ones, and also the IGBTs, I've already soldered them. You can see the solder is not finished there. Let's solder it. I'm done with the soldering. So let's now check the resistance again. You remember we're getting a very low resistance on the DC voltage, on the DC terminals. Let's check now that we've changed the MOSfets. Terminals. So these are your 2 terminals for the battery. Let's check with the meter. Okay, you see now we're getting 75 kilo ohm. So this is the board that we've just repaired. We're now having a good reading. You remember we're getting 3 ohms, so we're now getting a good reading. So one last thing, let's check the other most IGBTs, because we only check the inverter IGBTs. Now we have to also check the charging IGBTs. Let's check. These ones should get like 20 something ohms, 22. Let's just check there. Okay, I will have to zoom out. Okay, let's check them. The charging mode IGBTs, 22, 22, 22, 22. And let's check this diode. 0.4, it's okay. And also this other diode, let me check where is it located. It's connected to the, alright, it's here. So this diode here, you have to check it. Okay, 0.4, so we're reading okay. So one last thing, it's to change the capacitors. See, these capacitors, they're no longer okay, so we need to change them so that we can be safe. Otherwise we might have some problems. And also to cut the pins. You see these pins, they are long, the new IGBTs. Let's cut them and change the capacitors. Let's cut the pins. I'm just closing them so that they don't jump all over. So you can see those pins there. So I have to put them in the dustbin. Okay, let's now change the capacitors. So these are the two large capacitors. I've got replacement capacitors. Let's change them. Okay, we've got the IGBTs replaced. You can see those ones with the new blue insulation. Those are the IGBTs that we replaced. We also have the MOSfet, the 8 MOSfets replaced. You can see these MOSfets, these last ones and the other ones. These ones we have replaced them, and also the resistors on the MOSfets that drives the MOSfets we have replaced. Now we are going to test the inverter. I think it's time to test it. Let's have a look and see how it goes. Let's connect the control card. Let's hope for the best. Okay, let's connect the fans. If you don't connect the fans, obviously we're gonna get a 0-1 alarm. Some of the inverters, they don't run if there's 0-1 alarm. Connected the fence and the control board. Let's put some okay, let's connect the battery. Okay, let's just take out that display. Okay, I've got the display out. It's difficult to work with a cover because it takes a lot of space here, and it's not easy to work. So it's easier when we are like this, because I just want to make sure that there's a camera view on what I'm doing, because now you can see the fans are connected, the display is there, so everything is easy to see, because the cover will be closing some of the things. Let's connect the DC. Okay, I've got the battery connected. Let's try and switch on, because you see here this side there's 2 points for the switch. let's just put a screw there. Inverter is coming on. Okay, I took it out. Let's check something. Okay, I've decided to connect the screw there directly instead of holding it. The reason is, you see that screw there, it's connected to the switch. You know, these things we're working with high voltage, so I don't want to hold it there while the inverter is starting. I will not have no way to run. I must make sure when it blows, I've got a way to run. Otherwise, my hand will be stuck there. So let's be safe. So it's easy. It's safe if you leave the screw there. So if it blows, I'll jump. Right. Let's connect the power now. So the screw is in on the switch there. Yes. Look at the fence. There is the fence. There is the display. Now let's put the switch on, the power supply on. Hope it doesn't blow, Now it's gonna get image. So we're having 51. So we're having error 51. So as you have seen, we are having error 51. Some of the inverters, they don't work without the MPPT board. Let's just connect, because it detects that there's too much voltage on the PV. So I'm just gonna connect this cable. This one is for the current measurement and the voltage measurement for the PV. You can see this is the MPPT board. So I just connect that cable there. Let's see if it's gonna take it. Let's connect power again. So we're getting error 51. Let's check now. So now we're getting error 6. So there's no more error 51. Let's see. Okay, we are not yet winning on this inverter. We are having error 6. You saw initially we had error 51, but error 51 was caused by the MPPT board was not connected. So we connected the MPPT, so it disappeared. But now we are having error 6. So error 6, it's caused by the low voltage. If you've got the low voltage on the output, then it will give you that error 6. So that's why we're having error 6. So it means that instead of having 220 volts, we are having less than that. So obviously the inverter won't allow you to run like that. So what's causing that? The low voltage can be caused if the one of the MOSfet or the IGBTs, it's not fully switched on. So what's switching on the IGBT is the power that we get from the transformer here. You see these pins, there's a small transformer that produces power so that you can switch on the IGBTs. So if you take a look, let me turn it, you see that transformer there. This is the transformer that generates power to the IGBTs. So this is the transformer. So let me show you on the schematic so that you can see how it looks and how we can test that power supply. Okay, you see on the schematic there. So that small transformer, this is the small transformer here. You've got the AC coming in from the big switch mode power supply. And then it's gonna produce the voltage. So here you're gonna get 18 volts. You see here it should be 18 volts, and the other side it should be 5.6 volts. Then you also have another 1, 2, 3, 5.6 volts. So you are going to have a total of 6 Zener diodes. Those Zener diodes, they are there to stabilize the voltage, to make sure that the voltage doesn't go above the rating. So let's go back to the inverter so that we can see and test if the Zener diodes are okay. So you can see that we've got 6 Zener diodes. We have to get 18 volts and 5.6 volts. So here is our Zener diodes. Okay, let me put the multimeter there. Okay, so let's check our Zener diodes. I'm gonna connect power. Okay, so we should get 5 volts and 18 volts. See here, we've got 5 volts is fine. 5 volts is okay. 15 volts is okay. 5 volts is okay. Another 5 volts is okay. So it's the second one. Okay. So it's the third one. Last one. 15 volts. 5 volts. So the Zener diodes are okay. So let's check between the gate and the emitter of the IGBT. Gate emitter. So here we're getting 15 volts. 15 volts. 15 volts. 12 volts. So I'm 100% sure this is the one that's giving us problem. Okay, let's zoom it in, because we shouldn't get 12 volts, we should get 15 volts here. So it means that the circuit around here is not right. So you see there, we're getting 15 volts, 15 volts, and 15 volts. So this one, it means that this IGBT is not turned on enough, so it's gonna give that error 6. So let's see what's wrong on the circuit. I'm gonna zoom it in. Okay, let's check these resistors. So the first one, let's put in resistor mode. We are getting 10 kilo ohm, 46 ohm, 46 ohm, 47 ohm, 47. So on the circuit we've got 247 ohms and 48 kilo ohm. So here we are getting 10 kilo ohm, 46. So there's 47 ohm that's not right. So it's this one. So that's why we're getting that 12 volts. Let's change this resistor. It's 47R0. Okay, we've got the resistor replaced. Let's check the voltage now. See, now we're having 15 volts. Remember we had 12 volts there. Now we've got 15 volts. 15 volts. 15 volts. Yes. And 15 volts. So all of our voltages are okay. So let's test it again and see. Okay, we can now test the board. You can see this is the board that we repaired. You see those IGBTs that we changed and those 8 MOSfets. So let's test it now and see how it goes. So you remember we're having error 6. Let's check it now. Control pad. Alright. Okay, I'm going to connect the power now. Let's hope for the best. Let's connect positive and negative. Okay, the inverter is coming on. There we go. You can see we now have 230 out. So the inverter is working, no alarms. Let's check. You remember we're having a short circuit on the battery terminals. I'm gonna test there. You can see I've got 51 volts, no more 4 volts, that low voltage. So we're okay. Let's check the output. If we are going to have the output there and there. So we've got 230, exactly the same as what we are getting on the display. So in the inverter it's 100% okay. Hope this video is gonna help you to sort out this problem. We had different problems on this inverter. We had error 51, error 6, MOSfet, resistors. So those are the things that we have to take care of when you're repairing inverter. But right now the inverter is 100% working. But the one more last thing, we're gonna test it under load before we take it to the customer, and then we'll be happy with it, and then we can say the inverter is 100%. But as it is now, it's looking okay. So we're still gonna check the AC input, the solar panels, and all other things. So we are done with the repairs. Hope you like the video. Thank you very much, and I hope to see you on the next video. Thank you.